Out here, among the stars, lies the vastness of a universe we barely comprehend. Billions of galaxies, endless space, and a reality so immense, it feels impossible to grasp. It's beautiful, infinite, and unknowable. And there we are, a tiny blue dot spinning in the void. A home to countless lives, each moment unfolding in an intricate dance of time and change. From out here, Earth seems quiet, steady, serene. But as we move closer, we find ourselves immersed in the motion of life, a constant flow of movement, energy, and purpose. Every step, every breath, every fleeting second, a part of this grand story we call reality. But what if what we see is only part of the story? What if life isn't one continuous stream, but something else entirely? Like a film strip, frame by frame, moment by moment, stitched together by something far greater than we've ever imagined. This is the question at the heart of Triadic Theory, to uncover the truth about time, change, and the nature of reality itself. Let's step into the frames and explore the possibilities together. Time. We plan our lives around hours, minutes, and seconds, yet we rarely stop to ask, where did time come from? Our ancient ancestors didn't wear wristwatches or track minutes. To them, time was broader, marked by events like harvests, winters, or bedtime. With the invention of tools like sundials, time began to take form, dividing the day into rough segments, morning, noon, and night. As centuries passed, we broke it down further: dawn, midday, dusk. Water clocks gave us more precision, and eventually mechanical clocks segmented life into hours, minutes, and seconds. Today, modern technology can measure time in unimaginably small increments, essential for science and space exploration. Yet time itself remains a human invention, a framework we created, not discovered, to make sense of the world. Seasons, days, and seconds exist not as truths of the universe, but as tools of understanding and quantification. Time, when understood as the tool it is, serves us well. It helps us organize, measure, and bring structure to our lives. It allows us to plan, predict, and find patterns in the world around us.
4, 3, 2, 1. Ignition and liftoff of Ares 1X. Testing concepts for the future of new rocket design.
From scheduling a day to navigating the vast complexities of science, time offers a framework within which we can operate and thrive. However, when we misunderstand time, or forget that it is a construct of human invention, we risk confusing the tool for the truth. Time, as we perceive it, is not an inherent property of the universe, but a lens through which we interpret change and sequence. When we forget this, we begin to see anomalies and paradoxes that arise not from the fabric of reality itself, but from the limits of the framework we've created. This misunderstanding often leads us to build increasingly intricate explanations atop a shaky foundation, compounding our confusion. By mistaking the measurement for the reality, we risk losing sight of deeper truths about existence, causality, and the flow of events. Math has been one of humanity's most powerful tools for understanding the world. It began simply with sounds and words assigned to objects, a way to count, to measure, to make sense of what we saw. Over time, these basic associations evolved into a complex system capable of describing everything from the orbits of planets to the flow of electricity. But while math has helped us build and explore, it has its limitations. Ancient thinkers like Zeno of Elea discovered these limits through paradoxes that challenge the very foundations of mathematics. Zeno's paradoxes, such as the dichotomy and the arrow, reveal something startling. When math tries to describe certain aspects of time and motion, it begins to break down. These paradoxes hint at mysteries deeper than numbers, questions that math alone may not be able to answer. Take Zeno's dichotomy paradox. To move from one point to another, you must first cross halfway, and then halfway again, and again. With each step, the distance becomes infinitely smaller, suggesting that reaching a destination, and therefore motion itself, is impossible. Yet we move, and time flows, despite this contradiction. These paradoxes expose the gaps in our understanding, and they bring us to the deeper question: what lies between the frames of time? Imagine the moments of our life as a film strip. As we attempt to isolate a single frozen snapshot, an anomaly emerges. As the frames split apart, the moment is split in two, and the second half of the frame appears. We split the moment of time again, and again another frame appears. We begin to see a pattern. Each division reveals another frame, and another, endlessly smaller, as if time itself could be broken into infinite pieces. But this raises an unsettling question. What lies between these frames? Could it be that our understanding of time breaks down when we look too closely? Mathematical paradoxes often signal a deeper truth or a flaw in how we interpret reality. Here, the paradox between the frames suggests two possibilities. Either we're failing to measure what lies between them correctly, or perhaps, more profoundly, there's nothing there at all. If nothing exists between the frames, then each frame of time becomes a distinct moment, connected only by the illusion of motion and continuity. This changes everything we thought we knew about time. Is it truly a flow, or just a series of static moments we perceive as life unfolding? Even the way our eyes perceive the world reveals this mystery. The human retina has a blind spot, an area where no image is captured, because there are no photoreceptors. Yet we never notice it. Why? Because the brain fills in the blanks, drawing from the surrounding information to create a seamless picture. Could time work the same way? If there's truly nothing between the frames, perhaps it's not math that fails, but our perception that compensates. Just as the brain fills in the blind spot to make sense of vision, our consciousness might fill in the spaces between static moments, weaving the illusion of time's flow. To understand the importance of what exists between the frames of our life, we must first acknowledge that change is not the same as difference. Let's use this visual example of an apple. At first, we see an apple transitioning from red to green. This change unfolds over time, moving seamlessly as the colors blend. This is how we typically experience life, a flow, a process. But now, let's look again. Here we see the apple in two frames, one red, one green. There's no motion, no transition, just a difference. The red apple and the green apple exist independently of each other, with no connection between them. Change, as we perceive it, requires time. It's the process of moving from one state to another. But difference doesn't depend on time. It's the relationship between two separate moments, side by side, existing without a bridge. If we rethink change as difference, we open the door to understanding time not as a flow, but as a tool for measuring the gap that our consciousness perceives between moments. This perceived gap is interpreted by the tool we created called time. Imagine taking the linear frames of a film, each one capturing a moment in time, and cutting them apart. Now, instead of laying them out in sequence, stack them one on top of the other. In this arrangement, every moment exists simultaneously, not as a flow, but as a complete collection of experiences. What if our reality works the same way? What we perceive as a linear journey, past, present, and future, could instead be an instantaneous download. All the moments of our lives, all the choices, and all the outcomes exist at once, but our consciousness experiences them as a sequence made up of all the choices we make and the effect those choices have on other events in our reality. All calculated in a single act of instantaneous causality, a type of test or even a highly efficient way to create, develop, and test consciousness instantly without having to wait decades to understand what each individual might become. This shift in perspective challenges how we see time. Is it truly a river carrying us forward, or is it a lens showing us one frame at a time while the full picture already exists? Imagine everything in the universe suddenly comes to a complete stop. Every particle, every wave, every process motionless. Now, in that moment of stillness, we face a profound question. Does time continue on? If time is the measure of observable change, then without change, there's nothing to measure. Asking, how long were we still, reveals the contradiction. Without movement or difference, the question becomes meaningless. Time, as we understand it, depends entirely on the processes we observe. Without those processes, time itself has no function, no presence. It disappears. This thought experiment exposes an important truth. Time isn't a thing. It's not a substance, not an energy, not a force flowing through the universe. It's a construct, like numbers or language, created to describe the sequences of events we observe. Some might argue that time dilation, observed in experiments like atomic clocks or particle decay, proves that time is real. But these experiments don't measure time itself. They measure changes in processes relative to different conditions. What we call time dilation is simply the slowing of those processes, not evidence that time is stretching or compressing as a tangible entity. This leads to a deeper realization. If time can't be measured without change, it's not fundamental to the universe, it's a tool, a framework we use to make sense of reality. And while we don't have empirical evidence to disprove the existence of time, we do have logical evidence, common sense reasoning that shows time doesn't exist independently of the universe. Time, then, is not the flow of existence. It's the measurement of existence. It's how we quantify change, not something that exists on its own. Without change, time ceases to exist. And perhaps, in this realization, we begin to see the true nature of reality, not as a river of time, but as a universe of difference. Math, like time, was created to give us a language for the differences we observe in the universe. Numbers represent quantities, while operations like addition, subtraction, multiplication, and division describe the changes between them. Time, similarly, was given a language to describe duration. By applying numbers to time, we created units of measurement to simplify the complexity of change. But both math and time are constructs, human inventions, not inherent truths of the universe. Math cannot calculate time any more than it can calculate hope. Hope and time are intangible. They cannot be proven through empirical evidence. This doesn't mean hope doesn't exist. It means math isn't the tool to prove it. When we forget this, we create terms like space-time, which is no more logical than space-hope. The slowing or speeding of processes could just as easily be attributed to hope as to time. The math would still work, and observations would align as long as we assumed hope was the cause. This thought experiment highlights a simple truth: observing changes in processes and attributing them to a construct like time is no more scientific than attributing them to hope or love. Both are frameworks, not facts. Time zones are a human invention. To make sense of the Earth's rotation, we divided it into 24 segments, each representing an hour. But these lines are arbitrary. At the poles, where they converge, what time is it? The answer depends on what we decide. This reveals something profound. Time zones, like time itself, are constructs. They're tools we use to measure and organize, not intrinsic properties of the universe. In the same way, when we observe processes slowing or speeding up, we assign this to changes in time. But what if we're just assigning labels, as we do with time zones? What if the changes we observe have nothing to do with time at all? If humans had never existed on Earth, would math or time still exist? The concept of time dilation assumes that all processes function identically, regardless of slower speeds or lower gravity. But what if gravity and velocity fundamentally alter quantum processes in ways we have yet to understand? Attributing these changes to an invisible construct called time might cause us to overlook critical insights about why objects and processes slow down under such conditions. Triadic theory postulates that time and math are tools, methods for measuring the universe, not intrinsic components of the universe itself. Furthermore, it suggests that what we perceive as change might actually be difference, which does not require linear time. Humanity is young compared to the vast age of the universe. There is still much to learn, and it is unlikely that any one person or theory will provide all the answers. Yet every fact we hold today began as a question, then as a theory, before becoming a foundation of knowledge that withstood the test of time. If we allow assumptions to corrupt this process, we risk building a legacy of confusion destined to collapse. Triadic theory is a call to return to fact-based science, a science unclouded by titles, degrees, or positions of authority. In science, the only authority that has ever mattered is truth. If life is truly like a film strip, perhaps the answers to all our questions lie not within the frames, but in the space between them.